Alright guys, today I want to shoot a quick video and show you all how to measure a house for air infiltration. Basically that means how much air is coming in your house through your doors, through your windows, through the hose. I shot a quick video the other day about insulation. Alright, but now I want to show you how to actually measure for the air leakage. Alright, that is probably one of the biggest energy gobblers that we have. So we need to get in there and make sure that our houses are sealed up tight. You got to make sure that they're not sealed up too tight. Because if they're sealed too tight, then there's health concerns for that. And if it's sealed too loosely, I mean, if you have too much coming out, there's too much pollutants getting in the house, and that's a health concern. Plus, it causes your energy bills to go up a lot. So I'm going to show you how to do a blower door test. All right, and what that does is it measures infiltration. Alright, it's really not going to be a how-to video. It just kind of shows you what it is, and it gets you to open your eyes a little bit and let you know what is available, what kind of tools are available for you to use to help your homeowners out. Alright, so let's get started. Let me start off by showing you what a blower door is. Alright, the first thing you're going to need is a micro manometer. This is basically a manometer on crack. It's just a real sensitive manometer. Alright, this is one of the biggest expense when you're buying the blower door kit. I think these are right around $1,200. Alright, but I use the Retro Trek, and there's a Minneapolis blower door kit too, but they're the two biggest ones. Alright, this one I personally like this one a little bit better. It's easier for me to use, a little easier to navigate. Alright, it has a lot of functions. Like I said, today we're just going to cover measuring infiltration. Alright, the next thing you're going to need is the blower itself. This blower is it's got 8 blades. It's a variable speed blower. Okay, and here's the other side of it, and it's the actual variable speed blower there. Alright, what it has is it's got these different rings on here, and depending on the tightness of the house, would depend, like if your house is real loose, you're going to have it run it with no rings. My house, I believe, uses this ring. I don't have a super tight house. Then when you start getting into the really super tight houses, you start adjusting it by just popping out these little cones just pop out, the little caps pop out of them. Alright, so if you get a house that only has one of these, that's a really tight house. I haven't measured any houses like that, but I'm sure people have. Most houses that I've measured are in this ring category here. Alright, next thing you need is some vinyl tubing. Alright, so these are basically vacuum hoses. And this has actually got a communicating wire in it too. It's something like an Ethernet wire. Or telephone wire, it's the big telephone wire. And that's what is used to communicate between the manometer and the fan. So you got to have all this. Then you need your door frame. So what this is an aluminum frame. I'm going to adjust it where it fits my door. Sorry about I spilled some water on my camera and it's kind of messed up my exposure, but oh well. Alright, then it's got this tarp canvas thing that kind of fills in between the frame. And I'll show you how all this works. So let me put all this together and I'll show you how to measure a house. This is the blower door set up. Alright, so we got our fan inside the door frame there, and that's open to the outside. So what we'll do is we'll get this fan on, get it up to speed, and there is a certain number that I'm looking for as far as infiltration, and let me show you how I figure that real quick. Alright, to figure out how much air I should have coming into my house, here's a formula for it. Alright, so we need to start off by getting the base. It's the ventilator requirement for building, which is CFM equals 35 or 0.35 times volume divided by 60. Now to get your volume, that's the square footage of your house multiplied by the height of your ceiling. Alright, my house is 2,488 square foot with the basement. I have 8-foot ceilings, so it gets me at 19,904. That's the cubic foot of my house. Alright, so we would go 0.35 times the 19,904 divided by 60. So if you take 19,904 divided by 60, it gives me 4147 times 0.35. That equals 116. Now we need to convert that to CFM 50, something that the blower door can recognize. Alright, and to convert that to CFM 50, we need airflow times the N factor. Now my N factor, if you look right here, let me see if I can zoom in on this a little bit. If you look right here, I'm in the Louisville, Kentucky area. It's the white area. I'm in zone 2. If I come over here to zone 2, it's 17 to 20. Now I'm going to use 20. Now I have a single floor house, so the height correction is just 1. I'm just going to use that whole number. But if I had a 2-story house, I would take that 20 times 0.81 and I would use that for N factor. Alright, but like I said, I'm a single-story house, so I'm going to use 20. Now if I come back here to this, let me zoom out a little bit. It's my 116 for my CFM times my N factor 20. It gives me 2,320 CFM. Alright, so that's the maximum that I should have leaking into my house. Alright, now there is also a minimum. To get my minimum, we're going to multiply this by 70%. So I'm going to take 2320 divided by 0.7, and that's going to give me 1624. That's going to be my minimum. Now, if I'm anything lower than this, alright, then I'm almost required to get mechanical ventilation in here. Alright, so we need to have, and mechanical ventilation pretty much just something it can hook up to your furnace. It draws in the outdoor air, it conditions it, then it sends it into your furnace. Alright, so you can pick and choose when you want to bring in the outdoor air. You know, I guess it's better that way, but you got to get your house pretty tight before you start worrying about that. Alright, so my range needs to be somewhere between 1624 and 2320. Alright, so the first thing we're going to do is set up our micromanometer. I'm going to set up my time averaging. So what this going to do is it can take a reading every 2 seconds, 4 seconds, 8 seconds, 10 seconds, 20 seconds, minute, 2 minutes, so on. So we'll go 4 seconds on this one. Alright, next we're going to need to create a baseline. So I need my inside pressures and the outside pressures. I need a manometer to think that everything's the same. So I'm going to create a baseline. It's going to take the reading of the pressures inside and outside, and it's going to kind of zero everything out. I'm going to let it run for this way for about 20 seconds to get a good accurate reading. Okay, so it's been running for about 20 seconds now. So I've got my baseline set. Alright, then we'll come back to my manometer. Like I said, you got a bunch of different settings. You'll see it switching here. And I just want to make sure that we're on B. Alright, next I'm going to set my mode to flow. We're getting ready to fire this thing up, but before I do, we need to walk around. We need to make sure that your water heater is set to pilot, your heating cooling system thermostat is turned off, all your vent dampers are shut, especially your fireplace. We want to make sure that there's no fire in the fireplace. It will pull them ashes out and you could catch fire. If you have ashes in the fireplace, get some damp newspaper and put over top of it. That way you don't suck ashes all through your house. Alright. You need to get up in your attic and make sure... Sorry about that, guys. What I was saying is get up in your attic and make sure you don't have that vermiculite insulation. Basically it's like a pellet type insulation. That stuff does contain asbestos. And if it does, do not do this test. You will pull asbestos through your house. Okay, so just do a few things and make sure that all your exhaust fans are off. What I'm going to go ahead and do, I'm going to set my pressure at 50 Pascal. and I'm going to hit enter. When I do, the motor is going to kick on, and it's going to get my house to 50 pascals. So let's see what it does here. Where's my enter? There we are. Alright, you hear my motor kicking on. This is going to measure my flow here. Remember, I need to be, the maximum I should have is 2340. I'm a little higher, but when I first did this test, I was at like 3200 CFM, so I went out and spent about 50 bucks in silicone. I siliconed all my windows, around all my light fixtures. I just went around and I felt for my real heavy leaks, and I've gotten it down to 2460. Now I've still got some more work I need to do to my house, but you know, it's pretty tight. I'm happy with the way it is right now. Alright, with this thing running like this, basically what this is going to do is it's going to simulate a 20-mile-an-hour wind against all of your exterior walls. So kind of imagine having a 20-mile-an-hour wind blowing straight into the wall. Alright, that's basically what this test is going to be simulating. So if you walk through the house and you close your door just a little bit like that, leave it cracked, and you run your hand through here, if that room is leaking any air, you're going to feel it coming through here like crazy. This particular room is my daughter's room, and I'm not feeling anything coming out of here. So you can walk around throughout your whole house and kind of do this little test. You can see which rooms you need to work on the most just by the airflow coming through here. So this is the door to my bedroom. I'm feeling it, and I feel a lot of air coming through here. Alright, and I know what the problem is here. I've got another door going out to the back, and it needs to be weather stripped. When you're looking for leaks, you know, most of your leaks are going to be going into the attic. In order for that light fixture to work, I have to run an electric wire to it. So they have to drill a hole through your attic. Alright, just because that's mounted up against the drywall like that doesn't mean it's sealed off. So you need to get up there in the attic and seal where the wire comes through with foam or silicone. I did that, and also came down here and kind of siliconed around the base there. Alright, here's another problem that you have. To wire up to these electrical switches, they usually run your wire up your wall into the drywall or up into the ceiling, so they pop another hole in that top plate. So it actually pulls heat through here. Alright, and that's gonna suck. I mean, I feel air coming through here right now. Not a whole lot, but I feel it. But they make gaskets to go behind here, and again, you want to get up in your attic. Anywhere there's a wire coming through that drywall or coming through that top plate, it needs to be sealed up. Alright, so this is my wall. Alright, it has blown in insulation. I know for a fact I need more. I have a lot of wind wash up there too. What that does is the wind blows up through the soffits, and you hook up a thermal imaging camera, this is what you're going to get. So it's going to be able to show you where you're low on insulation. And like I said, when you have that blower door going, it really exaggerates this. So this is a perfect test with thermal imaging, because it really exaggerates it. Alright, here's one of my power switches. And this is with the blower door running with my thermal imaging camera. It's picking up heat coming out of there. Alright, this is one of my little pantries here. Alright, if you get it on thermal imaging camera, you can see all the heat coming in from here. This is one of the areas I've got to work on. This is a window that the previous owner installed himself. Let's see how well he did. Look down there. And we're looking at right there where the woodwork is. Alright. This is another area that I've got to seal up. Alright, just because you get good windows doesn't mean that they seal them up good. Here's one of my doors I've got going out to the back. It was leaking really bad, but you know, a little bit of silicone, I've got it looking pretty good in here now. So I got to work on that where the doors touch each other. I got to work on that seal right there, but for the most part, that door is sealed up a whole lot better than what it is, or what it used to be. Alright, this is a wood stove insert that I've got. I've got a leak right here because it's pulling up down through the chimney. You can usually tell where you have leaks. One thing's by dust and spider webs. Anywhere there's air movement, you're going to have spider webs. That's how they trap their animal, their feed. That's how they catch their food. Alright. Look at that down here blowing around. There's a lot of air coming in through right here. I'm just feeling tons of air. Let me get that on thermal imaging. Alright, so this is it. This is on the thermal imaging, all that bright orange there that's heat that's picking up. So all along that seam right there, it's leaking. I'm working on sealing this up now. I just kind of framed this in not too long ago, so these are still little areas I've got to work on. But you'll notice that fireplaces tend to leak a whole lot, so you want to make sure you got your dampers closed and try to seal them things up as best as you can. Alright, so here's where I got my blower door plugged into. If you look at that receptacle, you see all that orange coming out behind the plate there. And you see where the plug is plugged into. But you know, I've got a lot of heat coming in there, so I got to go through, and I've still got to air seal my attic, guys. With the motor running. So that's pretty cool. You can see my power cord wrapped up right there. 81 degrees is what it is. If you have these above your cabinets, alright, that's usually bad news, because that right there is normally open right to the attic. You need to get in your attic and check that. Chances are you can look right down in that box. If I scan mine with the thermal imaging cameras, you'll see exactly what I'm talking about. All that, let me get away from that light bulb, but all that is picking up all that heat out of the attic. So I have a lot of heat coming in through that drywall because, you know, it's just not sealed up properly. Bathroom exhaust fans. Them things leak bad. Make sure you got dampers in them. This one does not have a damper. It's going to though. It does have a damper, guys. I've just got it opened purposely just to show you how much heat you can be sucking in. Now if you look up here at this light where it goes through, this is one I have not sealed up yet, but you can see them spider webs I was telling you about. Anywhere there's air moving, they will build a web there to try to trap food. On my thermal imaging camera, you can see all that heat coming in here. Alright, so that's one of my next projects. I gotta go through here and seal up all my attic openings. Alright guys, this is the attic access. It's in a closet, in one of the bedroom closets. I've got it sealed up decent. It was a whole lot worse than this. We had all kinds of heat and air coming out through here. So I got some of that insulation board and I glued it to the top of the hatch. Then I put weather stripping all the way around it. I've still got to seal it up a little bit more, but right now that's where it's at. It's a whole lot better than what it was. Come back to my little chart here. I should be the maximum 2320. I balanced out right at about 2490. So I still have some improvements to do. I know a few areas that I got to fix. It wouldn't be very hard for me to get to here at all right at this point. Now I have a lot of work to get it down to 1624. Alright, so if I get below this number here, I'll need to get some kind of mechanical ventilation pulling. Alright, so I'm trying to shoot for right around this number here. Just whenever I get some free time, that's what I'm going to work on, and maybe I'll shoot another video and show you how low I can get it. Alright, I'm going to try to do the work myself, but I've been working in this field for a while. I know what to look for. If you're not familiar with construction, you want to get somebody that does air sealing professionally. It's not super expensive. What you can save on your utility bills will probably pay for itself in 3 or 4 years. So I keep my house at 78 degrees, and the 10 minutes I ran that thing, it shot it up to 82 degrees. So, you know, just that short bit of time, it rose the temperature in my house. So let's get these houses sealed up. You'll cut your bills down and you'll have a more comfortable home.